Hello guys, welcome to my YouTube channel, and in this video we are going to solve one classification problem in machine learning. So basically this mini project is about credit score classification. So what is the credit score? Credit score is the ability of the person is determined whether it has got credit worthiness or not, whether if some financial help is given or the loan is given to him, he can repay that amount or not. So this is how this mini project of credit classification works. So there are three credit ratings given by the bank, which is good, standard and poor. Poor means he cannot repay the loan or credit which he has taken, and good means he can pay that loan or credit given to him. So first of all, we will import the libraries necessary for this project, that is import numpy as np, import pandas as pd. Now for this we are not using matplotlib library or seaborn library for visualization. I have thought of using plotly library for this kind of visualization. So we will import plotly. Import plotly dot express as px, import plotly dot graph objects as go, import plotly dot io as pio, and now we will define one default template with the help of this pio dot templates dot default as plotly underscore white. So these libraries are imported and default template is set in its place. Now we will import our data. So data equal to pd dot read csv as it will read it is as a truncation operator, so we will have to give two backslashes for the proper address of this file. So now I will run it and it will read the file. Now we will check the first 5 rows of the data to study it. So the data has got ID column, customer ID, month, which month, name, age, SSN, occupation, annual income, monthly in hand salary, number of bank accounts, credit mix, outstanding debt, credit utilization ratio, credit history, age, payment of minimum amount, total EMI per month, amount invested, payment behavior, and lastly the credit score. So first of all, it has got 28 columns. We will check how many number of rows it is having. Data dot shape. So it has got 1 lakh rows. So first of all, we'll check the information it is carrying, all the 28 columns. So there is no null value, as we can see. There is int, float and object type of data in this. So As there is no null value, we can also once run and check whether the null values is present or not. Is null dot sum. Okay, is null. I forgot to give the brackets. So there are no null values as we have already seen in the info. Now we will check our target column, which is credit score, which determines the credit. This credit score determines the worthiness, credit worthiness of a person. So we will check it, what all values are there in credit score. Credit score dot value counts. So there are three kinds of credit worthiness rating, that is standard, poor and good. So first of all, we will apply some exploratory data analysis to understand a little bit about our data. So for that, I will visualize this. Like, first step what we are going to do is data visualization. So for that, what I am going to do is fig equal to px dot box data, and our x value is equal to we will take one by one each column, starting with occupation, and visualize our data. So occupation, here it is, occupation, color, is credit score, and we'll give the title credit score based on occupation. And we will make color discrete map I will use here, and for this I will give one dictionary type variable. So in dictionary I will mention these three values of credit score, that is poor is equal to 0 or red is the value, so it will mark with this color. Next is standard, so this I will mention yellow, and finally good. For good I will mention green. And now I will try to visualize this data by fig show. Let's just check what information it gives us to us. Okay, so according to box plot, there are no outliers in the data, and according to various occupation category, credit score is showing how many people are rated as poor and how many people are rated as good. So in this way we have done visualization for occupation. Next we'll try to check annual income. With the help of annual income, we will try to derive one relationship between credit score and annual income. So for this also I will use the same code, only I will make minor changes over here. So I will include here y equal to annual income color equal to credit score, same code, only I have just welcome one more column, that is annual income, and in the x I will pass credit score. So I will give here credit score, and before this I will use fig dot so I will use here update traces, and in this I will mention quartile quartile method equal to exclusive, that's it, and I will use fig dot show. So we can see there are few outliers in the data, and we have credit score and annual income. So I will write credit score based on this, should I will change it annual income. So this is based on annual income. So there are few outliers over here. And now we will check data visualization for another column. Oh, that is monthly in hand salary. Monthly in hand salary. Based on monthly in hand salary, and we will check what kind of data it shows. It have also got some outliers, and clearly the data is showing that there are higher number of people who have got good credit worthiness. Now we will compare this with number of bank accounts. So for this I will rewrite this code again. I will rewrite this code again, and instead of monthly in hand salary I will include number of bank accounts. So I will include here number of bank accounts and credit score based on number of bank accounts. Rest entire code is same. In this, according to number of bank accounts, it is showing that people with poor credit worthiness are more. Now we will check this for number of credit cards. So for this we will check now number of credit cards. For this I will rewrite this entire code. So for this I will use number of credit cards. So people with having no more or number of credit cards have poor credit worthiness. Even the visualized data can tell us this. Now we will check this for uh, interest rate. We will check this for interest rate. So for the interest rate also, so interest rate, and we'll check this for interest rate also, what kind of credit worthiness is there. So this is for interest rate. Okay, now I will check for number of loans. Next is number of loans. Visualizing data shows many insights. So we'll check for number of loans. So we will visualize this for number of loans. Okay, so more number of people are there with poor credit worthiness if their number of loan increases. Okay, now we will check it for type of loan. No, type of loan. Now we will check it for delay from due date. People with delay in due dates. People with delay in due dates. Because this also determines the credit worthiness, delay in due dates of a person. So we will visualize this also. Delay in due date. Okay, these also show people which have delayed due dates more are having poor credit worthiness. Okay, now we will check this for now we will just check this for number of delayed payments. Okay, because number of delayed payment also gives us the insight about the credit worthiness of a person. Number of delayed payment. So for this we will go up. Number of delayed payments, and I will copy this and try to visualize this plot. Okay, those who have delayed the payments more are having poor credit worthiness. Okay, now I will check this. Changed in credit limit. This will not affect much. Number of credit inquiries, this will not affect much. Okay, outstanding debt can have effect. So I will go for outstanding debt and visualize the data. So I will visualize this data for outstanding debt. So outstanding debt, and we will visualize this. People having more outstanding debt have poor credit worthiness. So lastly, uh, we have checked many columns which will affect credit utilization ratio, history, age, payment of minimum amount, total EMI per month, and monthly balance. These two parameter will also have effect on credit worthiness. So one by one I will visualize both of them and try to plot the relationship, and I will insert one more cell below, and I will go up and bring those columns. So total EMI per month, total EMI per month, and lastly monthly balance also. That's sufficient. We have checked all the columns which can have effects on credit score rating. Now I will visualize them one by one. Okay, people having more EMI per month. So there is no clear idea from this total EMI per month. It is showing balanced credit worthiness score. Similarly, we will check for monthly balance. People having more monthly balance have good credit worthiness. This shows that. Okay, now we will segregate our data. Before that, I will convert this categorical column of our credit score, that is good, standard and poor, into numerical column, that is data. I'll pick credit score. I can use label encoder also here, but I will use data credit score map function, that is map, and I will mention in the dictionary standard as one, good as two, and poor as 0. Now the data is converted into numerical. So first of all, I will segregate my data based on from sklearn dot model selection, import train test split, and I will segregate my data. So x is equal to np dot array data and the columns which I want to include. So for that, first I will import here before this one cell and write data dot info, so that all columns come in my front and I can select the columns. So customer ID and ID is not needed, month, name, age is not needed, annual income is needed because this will have effect. Annual income. Now I will monthly in hand salary. Monthly in hand salary. Now number of bank accounts will also have effect. I will include this number of bank accounts, and number of credit card will also affect it. So number of credit cards. Now interest rate, this will also have effect, so I will include interest rate. Now number of loan will also have effect on credit score, so I will include this also. Now delay from due date, this will also have effect. Now change credit limit will not have. Number of delayed payment, will have effect. Outstanding debt, this will also have. Credit mix will not have that much effect, so I am not including that. Outstanding debt. Credit history is also important. And monthly balance. So I have included all those column in X, and now our Y will be np dot array data credit score. So now we have segregated our data. Okay, there is one error. Okay, it's a key error. So I have forgotten to give one more braces over here. That's why it has shown the error. Now it's okay. Now we will train test split our data. X train, X test, Y train, Y test, train test split. I will pass X comma Y comma test size 0.3, random state 42, and we will divide our data. Now I will try to run, because this is a classification problem, ensemble, what we can say, ensemble techniques have more accuracy in that. So I will use ensemble sklearn.ensemble import. I will use bagging ensemble, that is random forest classifier, and I will say model equal to random forest classifier. I will give criteria equal to entropy and an estimators equal to 150, and I will do fitting over our training data, that is model.fit x train comma y train first. I will train my data. So it is getting trained. Once our data is trained, we'll calculate y prediction, that is model dot predict. Now our data is trained. We will X test and store the y prediction for us. Once it is done, we will check our accuracy of the model from sklearn dot metrics import accuracy score, and we will print accuracy score y test comma y pred. So we have got 80% accuracy. If we bring more hyperparameters and tune it using grid search, CV and etc., our model accuracy will automatically increase from 80% to more than this. So this was a small project on credit classification. Thank you. In next video we will meet with another mini project which will be helpful for you guys.